Hey guys, how's it going? Mike coming back at you with another video on college algebra. In the previous video, we talked about factoring polynomials, and we talked about some of the different ways and techniques that we can use to factor polynomials down into less complicated and nicer terms to work with. In this video, we are going to go over rational quantities, things involving x's, numbers, nth roots, all that kind of stuff. So a rational expression or a rational quantity, big thing is you want to know how to find the restricted values of a rational expression. And what are the restricted values? The restricted values are the number or numbers that make the bottom equal to 0. So what you want to do is you just want to take the bottom of your fraction, set it equal to 0, and if you have x's or something in there, then solve for x. As a case in point, I have 3x minus 1 divided by x squared plus 5x plus 6. If I take that bottom part and I set that equal to 0, and I solve for x, I'm going to get x equals negative 2, and x is equal to negative 3. I'll let you verify on your own that x squared plus 5x plus 6 breaks down into the factors x plus 2 and x plus 3. Not too hard, not too complicated to figure out that is indeed what it breaks down into. We are going to be coming back to this in more detail later on in the course, but just as a quick intro to rational quantities, things where we have x's being thrown in the mix, these restricted values are very, very important. Again, they are the x value or values that make the bottom of your rational expression equal to 0. A couple things to keep in mind when writing equivalent rational expressions. If I have a fraction a over b and I multiply the top and bottom by the same number c, then that resulting rational expression is the same. What we're doing is we're really just multiplying a over b by this odd looking 1, but we will be doing this quite a bit. In fact, within the next few slides, you'll be seeing one application of doing this kind of thing. So multiplying on the top and bottom of a fraction by the same number or just the same quantity overall, you're just multiplying it by 1. You're not changing the quantity that you have, but you're changing how that thing looks. When we add and subtract two fractions, two rational quantities, as long as the bottoms of the two or more fractions involved are the same, exactly the same, then you just add or subtract the tops of those fractions. So a over c plus b over c is a plus b over c, similar kind of thing for when you are subtracting. What if the denominators of your two rational quantities aren't the same? Well, if we're dividing or multiplying, then it is easy. First up, multiplication. If you're taking the product of two rational quantities, you're just multiplying the tops and you are multiplying the bottoms. So a over b times c over d is just ac over bd. If you are dividing two rational expressions, then as we just mentioned, that's easy as well. If you divide by a fraction or a rational quantity, that's the same thing as multiplying by the reciprocal of that rational expression or rational quantity. So saying a over b divided by c over d is saying the same thing as a over b times d over c. And by our multiplication property up top here, that is AD divided by BC. So if you have to divide by a fraction, just flip it, and then the division turns into multiplication. If we're adding or subtracting two rational quantities and the denominators are not the same, then it is a bit more complicated. There's a little bit of work that we have to do before we can add or subtract those things. So suppose we have two fractions, a over b, and I did plus c over d. It's a similar kind of thing if we are subtracting. We're going to create a common denominator between these two fractions. And the way we're going to do that is we're going to multiply the top and bottom of this first fraction here by d, and we're going to multiply the top and bottom of the second fraction here by b. And when you do that, again, you're not changing the fundamental quantity that you have. It's still the same quantity, you're just changing how it looks. And changing how it looks is okay, but changing the fundamental quantity itself is not. So when you multiply the top and bottom by d, you get a times d over b times d. If you multiply the top and bottom by b here, you get b times c over b times d. We now have the same bottoms in these two fractions, so now we just add the tops. And that gives us AD plus BC all over B times D. This is the same kind of thing if you were taking the difference of these two fractions. The only difference is that here there would be a minus sign. Lastly, simplify things if you have to. Pull out common factors, cancel out common factors, reduce things into smallest terms, all that good stuff. So just as one quick sample here, say we had 5 divided by x plus 7/3, and I wanted to write this all as one fraction here. Again, multiply the top and bottom of this first fraction by the bottom of this second fraction. So I have 5 times 3, which is 15, and then I have 3 times x, or 3x. Multiply the top and bottom of this fraction by the x. So 7x divided by 3x. And now the bottoms are the same. I can add these things up, and I have 15 plus 7x, all divided by 3x. So nothing too crazy happening there, pretty basic. Something that you should be familiar with in terms of just being able to take two fractions and you're trying to find the difference or sum, and you just create a common denominator and then take the difference or sum of the tops. A complex fraction is a fraction where the numerator and or denominator contain fractions themselves. So how are we going to simplify complex fractions? These things can get kind of confusing. They look really nasty, but hopefully this method will make it a lot easier for you to simplify these complex fractions, and they won't seem as bad. So first thing you're going to do is you're going to look at all of the denominators in each of the fractions within the complex fraction, and you're going to take the product of all of those things. So however many fractions you have happening within the larger overall fraction, take the bottoms of each of those things and take the product of all of those bottoms. Once you have that, you're going to multiply on the top and bottom of the big overall fraction by this product. This is, again, just multiplying by a weird, ugly-looking 1. Again, it's not changing the fundamental quantity that we have. It is just changing how it looks, though. And then once you have that all done, use the addition, subtraction, division properties of rational expressions, whatever you have to do in order to simplify that thing out. There's going to be some combining of terms, perhaps some canceling of terms, all that kind of stuff. But here's an example as to how we would use this process that we just went through. So here I have 5 over x minus 2 all over 3 over x minus 2 and then plus 1. So I'm going to look at this thing. I see two smaller fractions happening within the larger fraction. I got the 5 over x and the 3 over x minus 2. I'm going to take the bottoms of each of these fractions. I'm going to take their product. That was step 1. So my product that I'm working with here is x times x minus 2. And now I'm going to multiply on the top and bottom of this big fraction by that x times x minus 2. So that is just what I did right here. Now we multiply this entire thing into each term on the top, and then we multiply this entire thing into each term on the bottom. And we cancel terms out where we can. When I multiply this into this first term, the x on the top and the x on the bottom will cancel out. And when I multiply this into the 2 just stays. When I multiply this whole guy by this term here, the x minus 2 on the top cancels out with the x minus 2 on the bottom, and we're just left with 3x. And then I multiply the x times x minus 2 into the plus 1, and I just have x times x minus 2. So multiplying in leaves us right here as a result. Now all we do is we multiply terms in. For example, there, and there. And then we just combine like terms and simplify this thing out. And when you do all that, in the end you get minus 2x squared plus 9x minus 10, all divided by x squared plus x. We have the minus 2x times the x. That gives us our minus 2x squared. Minus 2x times minus 2 is a plus 4x. And then we have the 5x here. So 4x plus 5x gives me 9x. And then I have the 5 times the negative 2, or negative 10. So that's just one sort of review problem of how do we simplify these complex fractions here. Sometimes when we are given a rational quantity, sometimes radicals or roots will show up. We don't really like to leave radicals or just any kind of root whatsoever in the denominator of our fraction. So we need to take care of that. And how we take care of that is we rationalize the denominator. So if your denominator just has one radical in it, just the root of some quantity, we're going to multiply the top and the bottom of your rational quantity by the denominator of said quantity. So if I had, say, for example, 2x plus 1 divided by the square root of x, say. We don't like to leave this square root of x on the bottom, so therefore we are going to rationalize this thing so that we get rid of that root on the x, we just have x. So to do that, I multiply the entire fraction on the top and bottom by the same thing, and what I'm multiplying by is that square root of x. Now we're just multiplying two fractions, so we multiply the tops and we multiply the bottoms. And when we do that, we have the square root of x times the quantity 2x plus 1 all over the square root of x times the square root of x is just x. So really straightforward. This is very similar. In fact, it's the exact same thing to rationalizing the denominator when you had the square root of some number in the bottom. If you saw, or remember problems say like 5 divided by the square root of 7, and you multiplied on the top and bottom by the square root of 7, then you get 5 times the square root of 7 all over 7. And it's the exact same thing that is going on there. If we have the difference or sum of two radicals in the denominator, then we multiply on the top and bottom of your entire rational quantity by the conjugate of the denominator. Now, what is the conjugate? The conjugate has the same two radicals involved, but the sign between them is changed. So if you are given something that had a minus in the middle, you are going to multiply by the same thing, but the sign in the middle is now going to be plus. If you're given something that had a plus, you're going to multiply the same two things, but with a minus sign in the middle. So here's an example here. 6 divided by the square root of 7 minus the square root of 3. Again, I'm going to multiply on the top and bottom by the same thing, but now that thing that I'm multiplying by is the conjugate of the bottom here. So that's going to be the square root of 7 plus the square root of 3. And when we do this, when we multiply on the top and bottom by the conjugate of the bottom, what we're doing on the bottom there is we're really creating a difference of two perfect squares. So I'm going to have 6 times the square root of 7 plus the square root of 3. It's a squared, so the square root of 7 squared, or 7, minus b, the square root of 3 squared, which is 3. And this gives us 6 times the square root of 7 plus the square root of 3 all over 4, or 3 times square root of 7 plus the square root of 3 all over 2. So that is just another review problem as to how do we find the, or how do you rationalize the denominator of a rational expression where there is the sum or difference of two radicals in the denominator. So this concludes this video on rational expressions and rational quantities, all the things we can do with them. If you have any questions or comments, please be sure to reach out to me, send me an email, throw out the bat signal, send a carrier pigeon, send a telegraph, whatever you have to do. Until the next video, guys, take it easy.